Okay, good morning, good afternoon, or good evening. So now we will discuss section 2.5, which is the Euler-Maclaurin integration formula. So before this, we have discussed yung Bernoulli numbers and Bernoulli polynomials. So ang isang application ng Bernoulli functions o yung polynomials natin is yung derivation ng Euler-Maclaurin integration formula, which is really important lalo na sa calculus, especially when you're doing integration, no? So this integration formula is used for the development of an asymptotic expression for factorial functions. So yung factorial, familiar naman tayo doon, no? So check nyo na lang yung Stirling series. Ito yung may mga factorials. So this technique is basically repeated integration by parts. So I hope familiar kayo lahat sa IBP or integration by parts. And by using this expression. So we know na to get the derivative, for example, of a Bernoulli function polynomial b sub n of s, you only, since polynomial siya, so powers of n, all you have to do is to take the derivative, and kung power yon, so let's say bn, so you have to multiply yung baba mo yung exponent, so you have n, and then babawasan mo ng isa, so b sub n minus 1 of s. So let's start with this integration. So initially we have a function f of x, integral of f of x dx from 0 to 1. So we know na ang b sub 0 of x is just 1, right? So we can actually add b sub 0 of x dito sa integration kasi 1 lang naman siya. So since using this derivative relationship, we know na kapag kinuha mo ang first derivative ng b1, so b sub 1 prime of x is b sub 0, right? So we can add that. So bukod dito sa una nating nagawa, we now have these equalities, right? So we can express the simple integration as this one, or we can actually use this one kasi alam natin ang b sub 0 of x is 1, or just use the first derivative of b sub 1. It's the same, right? So using integration by parts, so we can let u as f of x, and then dv as b sub 1 prime of x. So lagi naman ganun, di ba? So therefore, ang du mo is f of x dx. Tama? If we do that, so let's, kung ito yung u mo, du is f of x dx, and dv is b prime sub 1 of x. So ang v mo is b sub 0 of x kasi first derivative naman nun. Sorry, b lang, b sub 1 prime kasi nga pala prime na pala to. So b sub 1 of x. Okay, ayusin ko lang so para mas maganda, let's rewrite this. Hold on. We have, okay, so derivative mo is f prime of x. Okay? So anong pwede natin gawin? Ang integration by parts is uv minus integral of b du. Tama? Sorry, may dx pala dito. Okay? So uv, so ang u mo is f of x. So u is f of x times b. So we have f of x b1. Okay? And evaluated at 0 and to 1. Okay? And then minus b du. So ang b natin is b1. So we have here b sub 1 f x. Ito yan. And then du. Du natin is f prime of x dx. So ito yan. F prime of x dx. And then ito yung ating v. Alright? So madaling i-evaluate itong una. So since 0 naman yung sa baba, so we have to subtract evaluated at 1 and then bawasan natin yung evaluated at 0. So f of 1, b sub 1 of 1 minus f of 0 times b sub 1 of 0. Okay? And then integration still remains this one. So we now have pwede nating alam natin ang b sub 1, right, is 1. Alam din natin na kahit i-evaluate mo to any values, kung 1 or 0, b sub 1 is just 1. So now, pwede natin gawin. Oh, sorry, wait lang. Alamin natin dapat to para malinaw. Okay, so balikan nyo na lang yung table. Ang b sub 1 natin of 1 is 1/2. Ang b sub 1 of 0 is negative 1/2. Okay, sorry guys. So, mali pala naisip ko kanina. So, we have f of 0, 1 and f of 0 still remains kasi hindi natin alam kung ano yung function. But we can have b sub 1 of 1 and b sub 1 of 0. So, dahil 1/2 isa, negative 1/2 isa, magiging positive to. So, we can factor out 1/2. Sorry, 1/2. And then we have times f1 minus f of 0 minus this integration. Okay? So, moreover, dahil balikan nyo itong integration na to, if you have b prime of 2 is just equivalent to 2 times b1 of x, which is galing lang dito. Okay? So, pwede natin gamitin yan, no? So, you have to do another integration by part. So, dito kasi sa sumunod na term is an integration, di ba? So, here, we let f prime of x as u, dv is b prime of, b sub 2 prime of x. So, ganun ulit, parang na-extend yung mga integration natin. So, using this assumption, we can have this. Magiging itong buong to will become 1/2 times f prime of x, b sub 2 x of x, evaluated from 0 to 1. Then plus 1/2, second derivative of f of x, and then b sub 2 x dx. Okay, so using that, you will have more terms here, and then you still have this integration. So you can actually do another letting din dyan, no? Kasi parang we can express yung mga itong b sub 1 into another polynomial, no? So general relation is ito. So we have b sub 1, b sub n of 1 is actually so negative 1 raised to n, b sub n of 0. So pwede mo i-relate ang b sub n of 1 sa b sub n of 0 with this expression, no? So therefore, kapag ang n mo ay 2, magiging square to, so magiging positive. So magiging ganito lang siya. B sub 2 of 1 is equal to b sub 2 of 0. So, nandito yun kanina. So we can, so dahil equal sila, we can just write that as, let's say, b sub 2 lang. Tama? So magiging lang, we can factor out b sub 2 of 0 here. Then still remain ito. And then, tuloy mo lang ulit yung integration using this. You will have this relation and mas mahaba na. Okay? So, para lang itong iterative integration. So, pahaba ng pahaba integration mo. And hanggang sa makarating ka sa mas general form. For example, kapag nakuha mo na to, no, you have to let again, u is f of third derivative of x and dv is b sub 4 prime of x. So, may ganyan. Okay? Medyo mahaba, no? So, isa-isahin nyo lang, guys. And then use this relation again. We can simplify further, no? Pinapakita lang nito na ang b4 or b sub 4 of 1 is just equal to b sub 4 of 0. Kung mapapansin nyo, valid ito sa mga even number na n. So for n equals 2, 4, makikita nyo kasi na yung negative 1 raised to n will become positive as long as even. So ganun yung nangyayari dyan. So anong mangyayari ngayon? We now have this expression. Ito yung una natin nakuha. And then secondly, ito, 1/2 b sub 0, b sub 2 of 0 times quantity f prime of 1 minus f prime of 0, f prime of 0, yeah. Minus 1 over 4 factorial, b of 0 times quantity, third derivative of 1 minus third derivative f evaluated at 0. And you have this one. So we can continue to do that, and we have this generalization. Okay, So itong unang term is yung dito. Hindi mo na kaya generalize pa yan. And then minus ito. So as you can see from here, we have 1/2. No? Itong nandito. Dito sa kabila is 1/4 factorial. Yung 1/2, it can be expressed as 1/2 factorial, right? And then we have b sub 2, we have b sub 4. So even numbers. And yung naka-multiply sub dito is first derivative. Ang naka-multiply dito is third derivative. If you look at it, kung ito ay n, so ibig sabihin nito is n minus 1, right? Or sabihin na lang natin add number. Kasi kung even to, add lagi ito. Similarly, we have b4. 4 is an even number and 3 is an odd. So pwede natin i-generalize. So magiging ganito siya. Okay? So magiging siyang 1/2p factorial. Yung p is from 0 to q, right? So let's say kung 1 to, so magiging 1 lang to, 1/2 lang yan. And this is the same here. Okay, and then ito ang representation ng odd number, 2p minus 1. Okay, kung naging 2 yung p mo, magiging 1/4, magiging b4, magiging 3, which is this one. Okay, and lastly, we still have this integration, which is ganito lang din naman siya. Okay, so this big expression is the Euler-Maclaurin integration formula. I'm not sure, I don't think na dinidiscuss ito sa 50 series or possibly, hindi ko sure. Pero maganda rin alam nyo, no? So basically, it assumes that function f of x has the required derivatives. Of course, di ba, continuous siya. Kasi kung hindi naman nag-exist yung kung ilang derivative niya, like f prime, f double prime, or f3, hindi naman valid na to. So we assume na ganun. So we can actually shift the range of integration. So anong pwedeng gawin, no? Pwede mo i-integrate from 0 to n. Kasi itong isa is 0 to 1 lang, di ba? If 0 to n yun, expand mo lang expression kasi ito is 0 to 1 lang. So madadagdagan ka ng maraming terms dyan. Okay? And then, we still have this term. Haba din siya. And ito, integration na ito, magiging ganito. Okay? So, as yung nasa mga bracket terms natin, ito is kung familiar kayo sa numerical integration, I'm not sure kung nagawa niyo na, pero I think sa higher level physics like physics 131, this will be discussed. Pero baka familiar na kayo before pa, no? So pwede kayo actually mag-program using any programming language, pwedeng MATLAB, etc., Python. And there are several ways to do numerical integration, no? Pwedeng Simpson rule, trapezoidal rule, etc. So, yan lang din yung relation nitong kuha natin na to doon sa mga yan. Okay? So, let's discuss briefly kung itong tinatawag nating Riemann zeta function. So, ito, nabanggit na ito before sa infinite series pa lang, no? Riemann zeta function is important lalo na sa pag-aaral ng prime numbers. And prime numbers are important sa, let's say, bank security, information security. Kasi bakit? Ang prime numbers ay special kasi nga they are numbers na ang factor nila is 1 in itself. So, di ba, alam naman natin yung mga factors and next multiplication is important din ano na sa pag-generate ng mga numbers. It's just important sa internet, mga security, kung ano man yan. Ano. So, ang general form niya is dito. So, zeta of s is the infinite sum of 1/n raised to s from, n from 1 to infinity. So, yung n mo ay yung nagbabago and s is any number here. With taking note na yung s is greater than 1. Kasi kung less than 1 yan, magkakaroon ka ng 2 raised to s, di ba? So, laging fractional yan. From 1, tas fractions na lang siya. Okay? If s is 1, definitely this is the just harmonic series, no? So, okay, so this is well known. The well-known Euler prime number product for the Riemann zeta function may be derived as this one. So if you multiply the zeta function by 1 quantity 1 minus 1 over 2s. So binomial lang ito i-multiply mo. And lahat ng terms na nandito, no? Ang mangyayari dyan is, multiply mo lang muna ng 1. So you have this. Right? Then multiply mo ng 1, negative 1 over 2 raised to s is this one. Ngayon ganyan. So ito, wala namang bago. And now if you multiply this, mangyayari dito, you have 1 over 2s. So pwede mawala yun, di ba? Kasi negative 1 over 2 raised to s can be subtracted to this one. Tama? And if you multiply this one to this one, so making negative 1 over 4 s. So meron 4s dito, 1 over 4s. Tama? And that's can be cancelled. So kung mapapansin nyo, ito even kasi siya, kahit i-multiply mo yung mga nito, magiging even. So makakancel lahat ng even numbers. So you now have this expression. So 1 plus 1/3, 1 over 3 raised to s plus 1 over 5 raised to s. So lahat ito nagiging well, in essential is prime numbers. Okay? You isolated yung mga multiple na may multiples of 2. Okay? So eliminating all terms like n raised to negative s, meaning 1 over s, where n is a multiple of 2. So ganyan yung ginawa natin. You now have this obtain that. So ngayon, kapag multiply mo naman siya, so you already have this one. And if you multiply everything by the quantity 1 minus 1 over 3 raised to s, so mangyayari dyan, multiply mo lang. So ito pa rin yung matitira kasi 1 lang na yung multiply mo. And then, multiply mo itong mga to. So as you can see, magiging 1/3 to, negative, mawawala din. And then, ito, magiging 3 times 5 is 15, no? So tinatanggal mo naman ngayon ng multiples of 3, no? So, by continuing, multiply mo ng 1 minus 1 over 5 raised to s, tuloy-tuloy mo lang, you will now have this general form. Ibig sabihin, if you multiply everything, itong zeta function natin by this quantity, 1 lang kasi na maaalis lahat. So this symbol, capital pi, is another special term for infinite. So yung sigma, we use for infinite sum. Pi, we use for infinite product. Kasi you can see here, this is product. Okay? Hindi siya sum here. Okay? So ito yung form ng Riemann zeta function in terms of infinite product. So as you can see initially, this is an infinite sum. Now we have infinite product. Okay? So yan lang yung tawag dito. Of course, I will not ask you to transform an infinite sum to infinite product. This is just to show you na may isa pang special type of parang function or mathematical concept. Okay? So yun lang muna for this, and next we will discuss 2.6, which is asymptotic series. Okay, so thank you sa pakikinig. Kapag may question, please join the consultation hours. Mas maganda na ganun kaysa naman like i-figure out nyo, like, of course maganda na i-figure out nyo yung mga nanditong discussion kasi kompleto naman. Okay, pero syempre mayroon pa rin time na hindi natin maintindihan, so consult with me. Okay, thank you sa pakikinig, and stay safe and have a nice day.